yourself and ask your question.
Assalamu alaikum warahmatullahi
Wabarakatuh.
Thank you very much, Doctor, for the insightful section. Yes, I just want to ask a question, because when it comes to choosing a model for our classification or other what's it called, other machine learning problem that we have.
Okay.
Because like in the last research show that you presented, you try KNN, XGBoost, and some other models like that.
Yeah.
But in this one, you use a logistic and SVM and some other one like. So what is the? It's just that, is it that we just make a point, just try one, or how do we go about selecting the best model for our problem?
Okay.
And that is one. Secondly, now if we want to improve this work or work on it now, maybe on its improvement, how can we come up with how can we get the data?
Okay, thank you very much. Now, so for the first question, like I said, we always keep it simple. You start from the simple one. You see, sometimes when you see experimental results, people usually start from very simple KNN, but sometimes if the performance are seriously too low, and of course, your writing also has limited space, that is why sometimes you might not have to report all the methods you have tried. You see, you can try, like for this work now, several methods have been tried, KNN, decision tree, several ones were tried. But however, if the performance are really, really low, they are not competing well, you can drop them in your reports, actually. Okay? So the one that you think are making sense or that contributing something, or that you can defend the way it is, you bring it up. And depending on the kind of space you have for the report you want to present. So in a simple form, when you want to select an algorithm, you have to start from this simple. Try this KNN decision tree, but and also for that support vector machine. Sometimes something don't work. Some would miss totally, even support vector machine, as powerful as it is, we've had cases whereby it doesn't perform. So you have to keep trying under ones and the lies. Of course, experience also matters. You see, based on experience, one student try a couple of things, we do, okay, can you use this? Why don't you use this? Try this one out. So for sure, there are a lot of trial and error when it comes to machine learning experiment. So, but the simple thing is, in order not to miss any opportunity, try from simple ones. But when simple ones don't work, then you have to keep moving up and finally having to go to ensemble. As you can see here, despite all what's done to the system, initially most of them were having individual algorithms were having very poor results. You can see here during the parameter optimization, you can see 80, none of them was entering 90 until feature selection came in and the like. So you have to try different parameter. Then depending on the kind of the word that works for you, imagine you have tried like 15. For sure, you cannot record 15. Of course, some people do it, but sometimes it's a sheer waste of time because some methods are just not working for that problem solving. So why including in the report? So that's why sometimes you might have to select like 3 or 4 or 5 competitive ones, except you just want to run investigating the performance of several algorithms on a particular problem. In that case, you have to include as much as possible. But in problem solving, you try several things, then you start dropping them as they are failing along the way. No, this one is having less than 80. I don't need it. We have like 3 or 4 or 5 that are performing close to maybe excellently well, 91 and above. We can choose a threshold. Okay, an algorithm that is performing 19 and above, I'm going to include it in my work. This is one way you can take the decision. But it doesn't mean that you have not tried simple ones, but they might not work for you. I hope that clarifies, okay? So there's no way you can just decide this is the algorithm to use. No, you have to try a couple of algorithms, then you are going to go for those that work for you for that particular application. If there are so many, then you can set a threshold Anyone above 85, I'm going to select it as part of my model, and then that is okay. As for the second question, that is the issue of the data set. Yeah. So for the data set, for whosoever might be interested in this kind of work, just get across to the principle you get across, even any paper online, get across to the author. If the data set is not included in the paper, get across to the author, send mail to them, then show your interest to work on that particular data. Some of the data sets are classified, I mean, they're confidential. The clinic might say, okay, you don't release it out except with their permission or with some condition. But by the time you discuss with the author might try to get permission from the appropriate quarter so that other people can also have a look and opportunity to explore and work towards improving these results. So whoever is interested, for sure, can come across, but sometimes it takes a little time to get the final approval from the owner of the data set. But for sure, people like that. For me personally, I've recommended the number of features need to be brought down. So which means people need to work in this particular area. Now, I hope that answers your question.
Yes, sir. Jazakumullah khair, Doctor.
Then Akim, okay, you still have something?
No. I will come later, inshallah.
Okay, Akim.
Assalamu alaikum warahmatullahi wabarakatuh.
Alaikum salatu wa barakatuh.
Jazakumullah khairan for your efforts. Yes.
Barakallah.
My questions are two. The first one is on the grid search. What you showed us, I mean, what I know, or what I read rather, is like when you use grid search, there should be like I mean, the arrays should be equal. They should be of the same size. For instance, maybe the two hyperparameters that are supposed to be tuned, maybe you are searching for maybe 5 in the first one, then the second one should also be 5. I don't know if this is right or wrong. Okay. How did you apply it in your experiment? And the second question is, I saw in what you discussed with us, SVM1, SVM2, and SVM3, and some other algorithms like that. I mean, how did you develop these different SVM1, 2, and 3? Despite that, you have, for instance, in this file you're showing us now, we have just one SVM there with the hyperparameters shown.
Okay.
So, I mean, how did you develop those other? Yes, in this one you have like SVM1, SVM2, SVM3. So were they? So that, I hope you understand my question.
Yeah. Your question is clear. Thank you very much. Yeah, thank you very much. Yeah. So let me start from the second question. So, which is the issue of generating the okay, let me start from the first, not to confuse people. On the grid search, yeah. For grid search, you know, there are lots of kind of implementation of grid search. The idea is you can use grid search for a system. It has its own limitation, sorry. So it has its own limitation in the sense that this systematic side, the simple one, whereby, let's say for a super vector machine, we have cost. The most important parameter when you're using the simple search method, you have to have a knowledge of the most important parameter, which is kernel. For super vector machine, this is kernel. So you select a kernel like polynomial. See, you keep all the parameter constant, select polynomial, select Gaussian, which one works for you. Once I get it to be, for example, here it is linear that is working here, then I'm going to fix it at linear one is working. I keep it fixed, I keep checking cost again, cost. However, grid search says you can search for these two together. So you're going to have, okay, what are the value of cost? What is the value of gamma, for example? Let's say we have a kind of graph. As we are changing this, we are also changing this. As we are changing this, we are changing this. However, there are a couple of recommendations. For example, some people recommend that when you want to use grid search, don't consider too many parameters. That is why personally, my students, because they want to save some time, they do go for grid search. At the case maybe we do use some of our solutions But I personally like to use the simple search method based on the knowledge of which parameter is more important. Kernel. I try to find out the best one first, and I keep it fixed. And I move to the next one, which is cost. The regularization factor. I try to get the best value for it again by changing it from 1, 2, 3, as many as possible, and I get it fixed. I move, so stage by stage, I can do that. However, for grid search, you do the two at the same time, because if you put too much values, it's going to take too much time. This is why people give a lot of condition. One of the conditions is that, okay, when you want to do grid search, try to check for many hyperparameters. Just select 2. They say, okay, just look for cos and gamma, and that should be fine. You ignore other hyperparameters. This is why I say this is not correct. I mean, it could make it deficient. You see, why some people will say exactly what you have just stated. That, okay, if you want to search for hyperparameter using grid search, reduce the number of values to 5. Just search for 5. 1, 2, 3, 4, 5. Then the second hyperparameter maybe 16, 25, 26, 27, then 30. 5 here, 5 here. The reason is because you are trying to run something now as like a polynomial degree. So to reduce the time, they say, okay, reduce the value. But there's nothing that says you have to do that, theoretically. You can keep the value as big as possible. 500 values to search, the other one 500 value. But you might run the experiment, it might not stop. This is why you see advices that, okay, don't make it to be more. Make it just few values. How do you do it? Now, what they say is this. So, for example, in order to reduce the computational complexity, they will ask you, okay, make it only 5. If you now get the result and you find out that the best result was gotten in the last value here. Let's say this is C and this is gamma, for example. The 5 and 5 gave you the best result. Now, the proponent of grid search says, since you are getting the best result, like 94%, in the last value here, they say you shouldn't stop. You need to run another grid search. Because since you are getting the best value in the last value here, there's possibility that if you increase this to 6, 7, 8, 9, 10, maybe you get better results. That's why in grid search in this egg, once you use the 5 value recommended, then and you get the last value here give you the best result, don't stop. Run another one for 6, 7, and 8. You'll be surprised that 7 might give you the best value, because you can see the trend. The result was increasing up to the last. But if you get the best value here, it means it's not likely anything better is here or anything better is here. So this is when people do grid search, not to waste too much time when you are running it, they give this kind of advices. However, if you have powerful machine, you can specify your grid value to be as many as possible. I hope it's clear.
Yes, exactly. My question actually was like, they should be, is it necessary that they should be balanced? I'm not particular about the number of values. Maybe for instance, we are looking at gamma,
balance. Okay. Thank you very much for that.
Yes.
Yeah, thank you. I'm sorry for missing that. That is where a grid, like I said, it depends on also maybe the version you are running, because there are so many free codes out there, depending on who are on it and the likes. But then there's no need to really make it. Maybe if a particular cost value is 1, this is a grade. See, when you say grid search, it's like this. This is grid search. See, this is grid search. It could just be an advice, okay? Yeah. So this is 1, 1, 2, 3, 4. This is 1, 2, 3, 4, 5, 6, 7. There's nothing wrong with it. It's me when this value is this, I can check this. So it can be any value. It could just be an advice, but there's no condition for that. Because some values, you might want to play with the particular value here, or it has been established that there's no need to have this particular value. We don't need to increase it to be in line with the other one. And the one that need more values, we don't need to deny it also those values. except there's a limitation for that particular implementation. So then you have to follow the one who wrote it because they made it limited. But also originally, the value should not be an issue, either 4 or 5, or they're the same or they're not the same. I hope that clarifies.
Yes, yes, sir.
Barakallahu feek. Thank you very much. Mr. Olayinka also.
I'm sorry, sir. The second one is on this SVM1, SVM2, and SVM3.
Okay, yeah, sorry. I thought I answered that. Thank you very much. Yeah, on the second question, thank you for that. You can see here, like I told you, one of the way to improve ensemble performance is to train so many values, so many ensembles. If I say 101, let's say we have a team of 5 people. We can say, okay, you go and develop like 25, 25, 25. Merge it together later. Hopefully we get better result. See, while running the experiment, they noticed during the grid search, see, they noticed that there was one SVM when the cost was 5 and gamma was 1, and using the same linear kernel, it has a result that is good, but not as good as this one, maybe a little different. Here, when the cost was 6, gamma was 0.1, and this is still linear, it has another good result. When cost was 3, gamma was 0.000, then still linear, it had another good result. And this is one thing I told you before. You can see it obeyed the rule. In support vector machine, once you fix the best kernel, it doesn't change easily. Other values can be changing. And the idea of ensemble is we want to get result from a little bit of independent classifiers. So this one is using a cost of 5. It means the hypothesis function is going to be different. Hypothesis function of this guy is going to be different because the value is different. So during the grid search, we noticed that maybe this one was getting like maybe 86. This one is getting 87. This one is getting 89. You can see that they're having close performance. So when we wanted to develop the ensemble, we say, okay, let's bring in these guys, 86 and 87, very close to 89. Bring them in, bring this one in, bring this one in. Maybe by the time they're going to vote, maybe they're going to get better result for us. And by the way, you can still increase the number. So let's say it's one of the recommendations, by the way, make it develop like maybe 51 SVMs. Because the idea of ensemble is the mistake that this one with 86% is making might be different from this, might be different from this. And we have demonstrated it before. How ensemble of 77%, 77%, they combine them together, they got 100% in their result. Because the mistake of this guy and this guy was different from this guy. Where these two guys agree, this guy will differ. Where these two guys agree, this one will differ. By so doing, you increase the final result of their voting. The same thing goes also for this one. Once you change the parameter, you can see cost here is 1, here is 7. But that same, even if the change of this one only, this is a different algorithm. So this is a different model. This is another different model because the hypothesis function is different. So once you run your grid search, you know it's going to give you a lot of results. You now look at those results, the one with good result, not the one getting like maybe 30, the one getting maybe closer to something acceptable. You can gather all of them together and use them to build an ensemble because it means they are performing, though not up to 100. Maybe by the time we get them together, they can give us better results. And that was why you can see that those things from 80 something, they were able to push themselves up to 94. I hope that clarifies.
Yes, sir.
Barakallahu feek. Thank you very much. So, Sefinat.
Assalamu alaikum warahmatullahi wabarakatuh.
Wa alaikum salam wa barakatuh.
Thank you to this session. I just want to ask,
Okay.
is there any benchmark for good or excellent features selected? What I mean is that in this explanation now, you had originally 444, of which 30 is selected. So, and you said it's not too good enough.
No, you said, sorry, come again. We have
You say
One,
in this presentation you are making to us today,
yeah.
out of 446 features,
Your
30 features
instance,
were
yeah.
selected.
Yeah, okay, go ahead. Yeah, I'm listening. Yeah,
Okay.
yeah,
Is it the instance or the features?
yeah. Okay.
Because I feel the instance might be records, but features which will be the number of features in each of the records,
Yeah.
sort of number of features in these instances. So I'm saying if 444, if we had originally 444 features,
Yeah.
am I right?
Yeah, no, that's it. That would be no,
That's the instance.
that is the instance. 446
Okay.
instance.
Instance,
Yeah.
okay.
The original feature actually was, we had 45 for one data, 196, and now 39 for another data. So we tried to merge it. We need to look for unique features among them. So we ended up having 31. 31 features.
1 out of around 200 plus features. Okay, and that still is not good because I'm working on in my work actually. I had 198 features. It's a clinical data, and after running a feature selection technique on it, I had 50 features selected. So I'm baffled if that, and it's giving me good result anyway. So I want to ask, is it okay?
Well, that is if that is the best you can have, just more for me to clarify, we didn't have 200 something feature. We had just, this is 196, 264. When you had it together, I think it's gonna give us 446 at the case maybe. We remove couple of maybe this to missing value and the like. But however, for this data has 45 feature, the maximum was 45. This one was 39. So when we try to mark them together, we have to look for unique features among them. Yeah, exactly. We have 31. Personally, our feature selection was able to select 30 as the best after 31.
Out of
31.
Okay.
Yeah. It was able to select 31.
I now understand because I joined.
Okay. It's okay.
I can now get it.
Okay, yeah. So 30. So, and that is using forward, and we try several ones, reduce the number. We couldn't get the best we are getting as at present.
Okay.
For your own case, having 55 from 198, that is a huge reduction. You see?
Yeah.
However, this is good. If it's giving good result, you try to reduce it can, if it is the first time, it can go, your report can go out. You can try to let the community, the research community know what you have done. I want to believe from 198 to 55 is a very big reduction. Maybe you or your team or another person will take it in future and try to reduce it further, because having 55 feature in medical is too much, to get the data is going to be a big issue. And we want to develop a system that can encourage people to utilize it. Once people know that you are going to need 50 features to run it, people run away, it discourages people from participating. That is one of these reasons why, even when we get 15, I still encourage people to go for more reduction, because we've gotten 5 or even 3. You see, getting the same accuracy. But you cannot satisfy the accuracy for reduction of the feature. If 55 is what you can do for now, I think this is okay. Yeah.
Okay, Jazakumullah.
Barakallahu feek. So I think people, I see we have 1 or 2. Mr. Mohammed Balogun.
Assalamu alaikum. Yes, I have some other questions I want to ask.
Okay.
So the first question I want to ask is that, because after developing using the algorithm and we see that it performs very well on the data and on prediction, how can we answer this question of how reliable is our model, or how reliable it is that what we are predicting is actually the case, or can how it will be deployed in usage?
Okay, in the real life.
Yes. Then secondly, the other thing I want to ask about is that I work on one data set recently about injury prediction of athletes. So when there are about 70 features in that particular so we are able to get something using the KNN and some other things. So we saw that the KNN performs better on the data set.
Yeah.
So, but the problem I'm having is that because the data is very large and it is taken on a daily basis. Although there are 10 features. I mean, no, there are 7 features. Yeah, there are 10 features, but they are repeated on 7 days. That is 7 days of the week. So to predict so I'm not looking at what are the ways that we can improve because we also try to do feature selection, but we find it very difficult due to the time frame between the project and the submission. So that's when we just leave it at that particular level.
Okay.
Thank you, sir.
Okay, thank you very much. If I understand your question very well. For the first one, yeah, as for reliability, you see, we have proof of concept, what we call proof of concept. Proof of concept is, that's why you use cross-validation. So in addition to using it when the data is very few, you also use cross-validation to prove to people that this data can work. Modeling can work for this data. Because then you are going to use every part of the data to do validation at least one time. Now, this is a kind of proof of concept that this thing might work. But however, to be able to really satisfy in the real world, then you need to have enough data that you are going to divide into at least 3. You can divide into 5, by the way, but 3, the minimum standard, which you're going to have training, validation, and then final testing. So if you can run it, then the performance measure you are going to see will also determine, is it really random? It is not random. That's why some people say, okay, whatever experiment you are running, you can run it many times and find the average. You see, you run the experiment like 20 times or 10 times and find the average. And every time you also look at the result of the run and the average is acceptable. That means the reliability of the system is high. And this is where I don't recommend the classical neural network. Classical neural network, sometimes you can give you like 90, another time 70. So there are some algorithms that are known not to be stable. See, their performance could change by little perturbation. So in that case, the option somebody goes for really matters. But then one way to be sure it's going to be reliable, it will have enough data to test it. But if the data is not yet enough, use cross-validation at least to check that, okay, this is a proof of concept that this thing can work and it's going to be reliable. But the reliability is something you need data to test, and also to run multiple times and see what result you are getting in each of the runs. That is one of the ways you can check for reliability. As for the second question regarding your project, where it depends on the project and the further detail about it. So depend on the nature of your data sets. So, and then we can be able to give you informed decision about it. So later you can engage with me, we can discuss it, and then we'll be able to see, okay, what are the issues you are facing? Like you said, the features like 7 and they are taking in different days. It doesn't matter how many days they took it. If the features are different, then you might try to do feature selection. Then how many samples do you have? If the number of samples are many, then the features, so if the number of features are many, reducing the number of features is the number one thing that can increase the performance. Because features, the more the feature, the more the samples you need. And sometimes the samples are fixed. So hopefully, we've heard it before on feature selection and the importance of feature selection. Maybe one of these days we will still discuss about it, the importance of feature selection and how it solves the problem of cost of dimensionality. It's a very big problem in machine learning. So, however, if you don't have problem of feature selection, your features are not many, and you have so much samples. For example, if you have 7 features, as you are saying, ideally, seven features, rough estimation, you should have like 10 raised to the power 7 samples. That is like how many zeros, eh? So I don't think, I'm not sure if your data is up to that. Otherwise, it may even this 7 features might be too much.
It's 70 features, sir. 70.
70 features? How many samples?
It's very large. The samples are large.
Yeah, I mean like 2 million or 3 million.
I can't actually recall
Okay.
the actual value.
Okay, no
but
problem.
it's-
You can engage with me later. I will give you more informed advice on how to kick the result up. Okay. Yeah.
Okay, sir. Thank you. Sir.
But 70 feature for anything is too much. For sure, you have to do feature selection to bring it down. So 70 feature is much. So because you're gonna be for 70 feature, you are in need of 10 raised to power 70 samples. I'm not sure you have that. That's how many 70 zeros. That's going to be huge number. It might not run on your computer if you have it. Yeah. So in that case, reduce the number of features matter. Also, you might want to do pre-processing like normalization. If your data is not really giving you good result, you may need to normalize your data. So maybe the unit of the features are different. You need to normalize it. Sometimes normalization also might make you to be able to get improved result. And of course, make sure you select the appropriate, check as many algorithms starting from simple to the complex, while paying more attention to the hyperparameter optimization of those algorithms. Hopefully those should be able to give you an headway on how to improve your work. Barakallahu feek.
Thank you very much, sir.
You're welcome, sir. And Mr. Kim, is there another question?
Yes, sir. It's additional question. Yeah,
Oh, yeah.
My question is about the smooth. What would be the best approach? Because I read in some papers like some of them would do like 35%, 50%, 100%.
Okay.
What would be the best approach, or what is most advisable concerning this sport?
Okay, thank you very much. Well, as for this, for the smooth, see, it's just a method that okay, you want to, when you have imbalanced data. See, when you have imbalanced data, yeah, we have it here. When you have imbalanced data, we can do undersampling, and then you can do oversampling. Because balancing means I have class A, I have class B. This one is like 500, while this one is 200. The number of sample here is less than this. So you can do undersampling. Undersampling means you reduce this also to 200. So everything will be 200, 200. This is called undersampling. This is what some people really recommend more. That don't use fake data. Another way is you increase this one. This is 500. You need to increase this one to also 500. That's the percentage he is mentioning. So the question now is, how do you generate this extra 200? You know, now we are generating extra 300. We need to add 300 to this 200 to make 500. How do we generate it? That is where that percentage is mentioning came from. That is, do you 100% means you repeat this whole data. You have to repeat the complete data. Every data will be part of the repetition. Why percentage means, okay, just 50% of the data. Use 50% of the data and try to repeat it as much as possible until you get to 500. Because even if you use 100%, if you increase this one by 100%, it's going to be 400. You see, another 100% will not generate the number you need. So you need to do some again, which is some of them will have to be maybe 50% of them again. So there is no really the best value for it. It's part of the experimental setting that we have to check out. By the way, somebody might want to investigate the effect of that percentage you mentioned on the performance of smooth, how it affected. If I increase it by so percentage, how is it going to affect? If I increase it by 50, how is it going to affect? If I increase it by 100, how is it going to affect? Again, the fact that it affects you in one data might not affect in the same way for another data, which means the principle of let the data speak holds. So it depends on the data set that we are using. So there is no one that is better or best for all. In fact, as a matter of fact, if your data is much, like you have like 800 and then 600, maybe sometimes it's good to just go for 600, 600. Reduce, kick out some from this extra and let them be the same. We have people who criticize that smooth is generated for oversampling. You are generating a kind of fake data or repeated data, as the case may be. So you have to try out a couple of options and then see which one work for the work you are working on. And if you don't do oversampling, it puts you on a safer side, but sometimes oversampling also is very highly acceptable once you document your work very well. Barakallahu Feek. I hope that clarifies.
Yes, sir. Jazakumullah khairan.
Barakallahu Feek. So I think we might be taking the last question today because of our time. Ms. Olayinka.
Naam, assalamu alaikum.
Wa alaikum salam wa rahmatullahi wa barakatuh.
Yeah, Prof. Mine is just a clarification.
Okay.
If you look at the current slide you showed on the screen, there is a percentage split that talked about stratified ratio.
Yeah.
Yeah. So I want to clarify the meaning of stratified in this sense, because if you go to sampling method in statistics, there is an understanding I know of stratified or stratification when you stratify sampling. And I want to be sure that maybe it is used differently when it comes to machine learning algorithm, because there, what stratified will mean is that I have an heterogeneous data set. Heterogeneous in terms of maybe if I take gender into consideration, I have a data set that has both males and females. And if I want to do the sampling, I want fair representation of both males and females.
Excellent.
So in that, yeah, so that is stratification. Or for instance, I have male, youth, and adults, and I want the three of them in fair proportion. I will now take a certain percentage from each of them, so which will now be a representation of those homogeneous category. Yeah, so but here now, 70% training and 30% for testing. So I think at the issue, the training contains all the features that would also be retained for the testing. So I wouldn't know where the stratification comes in. I had thought maybe it is gender that you want to really stratify on its basis, but I'm really not clear about it.
Okay, thank you very much. It's clear. So it's the same principle like, machine learning, computer science, they take all this from statistics, mathematics, and the like. So it's the same principle you just explained. However, how we use it here is like this. You see? Yeah. Here, stratify ratio, stratify sampling, we use it to divide our data to ensure fair representation, just like you mentioned. This data set is made up of rheumatoid disease and non-disease. Somebody sick and known that is not sick, which we call positive and negative. Now, so when we have this data, the data set is 100%, which means we have, after the balancing, we have, let's say, 500 samples that are disease and 500 samples that has no disease. However, when you break your data set, if you don't use stratified ratio, then you can have a situation whereby 70% is going to have like 40, 70%, 40% will be from class A, 30% will be from class B. We don't want this. This is what we mean by stratify. Stratify will make sure that when you select 70%, it will equally represent class A and class B. In the case of your example, you use gender. This class A or class B is serving as the gender now. Let's say this is male, this is female. But in our case, this is someone that has a disease, and this is the one that has no disease. So when you divide your data, the 70% must be stratified. That is, they must have equal number of samples from both classes, or if not equal, very close. Because if you have odd numbers, you might not be able to get equal. But if you don't have odd number, they must be equal. It means in 70%, you must have the same number of rheumatoid disease patient and the same number of people without disease. For testing case also, the 30% must be 15% from one class, 15% from the other class. This is what we call stratified sampling ratio when we are doing machine learning modeling. So, and I want to believe
Yeah,
it's the
thank you,
same
thank
thing.
you, Prof.
Yeah.
Yeah, it is clearer now. I think
Okay.
incidentally, in your discussion then, the stratification did not reflect the diseased or non-diseased. So it just centered on the training and testing. I was not thinking what was the basis for the stratification there. But now it's much clearer. The stratification is based on those that are diseased and those that are not diseased. We are reflecting them both in the testing and the training set.
Yeah. Thank you very much.
Yeah.
And thank you for bringing the commission up, because so I was saying it because I thought everybody understand that. Sorry for that. Yeah. So when you say stratify, it's a very common word we use when we do division of data set. So we want to make sure that, because every data has a tail. You have a very long data. This is sample one. The target is the one that attached to it. This is true. Another sample, this is false. Another sample, this is true. So this one is the one that we are. So when we talk of stratify, this is the one that will determine if it is stratified or not. So you must have equal percentage of true, false in both the training and the testing. Thank you very much for that. So, and this is the advantage of question time. Jazakumullah khairan all.